Hello students, myself Mrs.Nikita Patil, Assistant Professor, Changu Kana Thakur, Arts, Commerce and Science, College New Panvel, Empowered Autonomous. Today we are discussing the terms that is graph in the data structure. So let us see what exactly the graph. So what is graph? A graph is a non-linear data structure. Why it is called as non-linear? Because it has a no sequence. You can start off with the any sequence like made up of vertices and edges that represent relationship between the object. So there will be the two main components, that will be your vertices, we are called as the nodes, and the edges that we can use for the connection purpose. Unlike array or the linked list, graph do not follow a sequential order. For example, on a map, each city is a vertex and each road connecting to the city is your edges. This way a graph represents how cities are linked with each other. Now let us see the components of the graph in the data structure. So there is the main two component, that is vertices, and second one is the edges. So vertices are the fundamental unit of the graph. Some things vertices are also known as the vertex of or the nodes. Every node or the vertex can be labeled or the unlabeled. We are considering it will be the weighted also. Now edges, second term will be the edges. Edges are drawn or used to connect two nodes of the graph. It can be ordered pair of the nodes in a directed graph. Edges can connect any two nodes in any possible way. There are no rules. Sometimes edges can also known as the accents also. Every edges can be labeled or the unlabeled. Next will be the traversing techniques of the graph. Before traversing techniques, there will be the types of the graph, that is undirected graph and directed graph. See that graph is the non-linear data structure. So it, if you are pressing the directions, we are consider as the directed graph, and if you do not accessing the directions, then we are consider as the undirected graph. Based upon that, the techniques will be there, that is how to traverse the graph in the data structure. So traversing techniques are used to visit all the vertices of the graph systematically. So these method helps to explore the graph completely and are useful solving many graphs related the problem. So graph will be traversed into the two components, that is the first one is your depth first search and second one is the breadth first search, like BFS and the DFS. So DFS means explore as far as possible along each branches before backtracking, use a stack or recursion. And the BFS is exploring all neighbors of the vertices before moving to the next level, use as the queue. So let us discuss about the depth first search in detail and then breadth first search. So we are start with the depth first search or the DFS for a graph. So depth first search is a graph traverses method that starts from a source vertex and explore each path completely before backtracking and exploring other path. So to avoid reversing nodes in the graph with vertex, visited any array is used to track visited vertices. So these algorithms traverse a graph in a depthward motions and use a stack to remember to get the next vertex to start a search with a dead end occurs in any iterations. So traversing for the depth first search, there will be the some rules. So first rule will be visit the adjacent unvisited vertex, make it visited, display it and push it into the stacks. Rule 2 will be if no adjacent vertex is found, pop up the vertex from the stack. It will be pop up the vertex from the stack which do not have adjacent vertex. Now rule 3 will repeat rule 1 and 2 until stacks is empty. Now let us see how the stack will be traversed using the DFS algorithm with the help of the diagram. So consider this one is your the example of the DFS. See in the above diagram that S is your root node, then S has the child that is A, B and the C, and then A has the child D, B has the child E and the C has the child F and the D has the graph G. Okay, So these graph we are traverse with the DFS. So what is our first rule? That we are start with the unvisited node and we are consider that is considered we are push it into the stack. Now our root node is your S. Always we are start with the root node. So S we can visit it and it will be put it into the stack. Now the second one is that we have to check the adjacent nodes of our particular nodes, visited nodes. So what is our adjacent node? The A is our adjacent node, again B is our adjacent node and the C is also adjacent node. But we are uh, take it as the alphabetical order. So we are considering after the S we are putting the A into the stack. After that the A has the, then after that we have the next, that is adjacent node, that will be the B. So after S we have visited the A, it will put it into the stack. After A it will be the D, which is put it into the stack, and after D the D has the adjacent node, that is G. So we are put it into the graph. And after G there will be the three adjacent nodes like D, E and F, but already D is visited, so we are consider that E and F are the adjacent node. So firstly we are consider as the E alphabetically order, so we are put it into the stack. After E we are putting the B, and then G has the remaining adjacent node, that is the F, and next one is the C. So our traversing path, the output of our DFS algorithm is first is S, then A, then D, then G, then it will become to the E, E after it will be the B, then F and the C. These are the outputs of the DFS algorithm. Now let us consider next algorithm, that is the BFS. Okay, so BFS is the breadth first search or the BFS for a graph. Now the DFS is the downward and the BFS is the backtracker. So breadth first search algorithm traverses a graph in a breadthward motion to search a graph that structure of a node that meets a set of criteria. It uses a queue to remember the next vertex to start a search when a dead end occurs in any iterations. Breadth first search algorithm starts at the tree root and explore all nodes that represent the depth prior to the moving on to the nodes at the next depth level. The BFS differs from the DFS in the way closest vertices are visited before other. We mainly traverse vertices level by the level. Popular graph algorithms like Dijkstra, Prim's algorithm, we are based upon the breadth first search. BFS itself can be used to detect a cycle directed and undirected graph, find shortest path in an unweighted graph, and many more problems. So see the rules how your BFS will be happen. So first will be visit the adjacent unvisited vertex set, mark it visited and display it and insert into the queue. If no adjacent vertex is found, remove from the first vertex from the queue. Repeat the rule 1 and 2 until the queue is empty. Now consider the same diagram, that S is our root node and the B, C are the adjacent of the node A. So we are start with the S node which is put it into the queue like as the visited vertices. Now we are considering with the alphabetical order that A is our first, then we are put it into the queue, then after A that second adjacent word, that is the B, and after it will be the C. Now S adjacent all vertex are visited, so S will be the pop out from the queue. Now next one will be the A has the adjacent node, that will be the D. So A is also visited and their adjacent nodes also visited, so A is out. Now second node will be the B, so B has the adjacent node E and the B is out. Then third one will be the C has the next node, that is the F. Likewise, after completions of the all the visited nodes, the D has the last vertex in the level, there has the vertex, that is the G. So our BFS traversal path will be as A, B, C, then it will be the D, E, F and the G. So these are the final result of the BFS. So in the BFS and the DFS, the difference is that in the DFS we are considering as the depth of the tree, and in the BFS we are checking the level of the tree. So these are the main difference of the BFS and DFS. Thank you.